Hey Mim, I'm just boiling some water to make some ramen. Dear Mim and Toby, why is ice cold and why is steam hot? How does water become the two? Great question, Karen. Matter, such as water, can transform into different states, solid, liquid, or gas. When water is solid, it is ice. When it is liquid, it is water. And when it is gas, it is steam. These changes in the state of matter the water is in are called phase changes. Phase changes are when water changes from one state to another and occurs when there is sufficient energy change in the system. When water is melting or boiling, heat is applied to the system. This is what is called an endothermic process. And when water freezes or condenses, heat is removed. This is an exothermic process. These changes in the state of water occur at specific points called the boiling point and freezing point. Yeah, the boiling point was what the water was at. All substances have specific points at which they change their state of matter. These specific points are due to the intermolecular forces between molecules in the substance. Intermolecular forces are interactions that occur between molecules, not to be confused with intramolecular forces, which are forces within a molecule. When two particles experience an intermolecular force, a slight positive charge on one particle is attracted to the slight negative charge on other particles. When intermolecular forces are strong, molecules are strongly attracted to each other. Molecules experience different types of intermolecular forces: London dispersion forces, dipole-dipole interactions, and hydrogen bonds. London dispersion forces, the weakest intermolecular force, are temporary attractive forces that occur when two adjacent atoms experience temporary dipoles. Stronger dipole-dipole interactions occur between polar molecules due to the uneven distribution of electrons between atoms in a molecule. The attractive force occurs between the positive side of one polar molecule and the negative side of another. Even stronger are hydrogen bonds, which are a specific type of dipole-dipole interaction that occurs in water. Hydrogen bonds are attractive forces between a hydrogen bonded to an electronegative atom and the lone pair containing electronegative atom of another molecule. When water is boiling and turning into steam, it is changing phases from liquid to gas. On a molecular level, the intermolecular forces between the water molecules are decreasing. Energy is absorbed when bonds are broken, and in this case, energy is put into the system, breaking the intermolecular forces. The heat applied to the water is providing enough energy for the intermolecular forces to break, allowing for the increased movement and distance between the water molecules. As water boils, its various intermolecular forces are broken. The bonds are also unable to form when molecules are very far apart and traveling very fast. Steam contains all the energy used to break the intermolecular forces in water, so it has more energy and faster traveling molecules, therefore making it hot. On the other hand, when water freezes and turns into ice, it is changing phases from liquid to solid. Energy is released when bonds are formed, and in this case, energy is removed, forming the intermolecular forces. The intermolecular forces between the water molecules are increasing because when freezing, water molecules move around more slowly, making it easier for them to form the various intermolecular forces to arrange themselves into a solid structure. The molecules in ice move slowly and have less energy, and the intermolecular forces in ice are broken when heat is applied to it, therefore making it cold. All of this relates to the enthalpy of water. In order to calculate how much energy is needed for water to undergo these changes, a few things must be considered. Specific heat is the amount of energy needed to raise a specific amount of a substance per unit of temperature. Enthalpy of fusion is the energy needed to turn an amount of liquid substance to a solid. Enthalpy of vaporization is the energy needed to turn an amount of liquid substance to a gas. Since enthalpy is a state function, a change of sign represents a change of direction of energy, and a difference between melting and freezing, or heating and cooling. Here's the heating curve of water. As you can see, the steepness of the slopes represent the heat capacity of different phases of water, and the lengths of the areas with zero slope represent the enthalpy of fusion and vaporization of water. Since water can only change states at its melting and boiling points, the energy needed to get to these respective points must be calculated first, with the enthalpy of fusion or vaporization being calculated after. To get from a cool liquid to a hot gas, heat needed to warm the liquid to a boiling point is added to heat needed for vaporization of the liquid, which is then added to heat needed to warm the gas to the desired temperature. A reversal of the sign of heat is enough to find the reverse of the process. These values for calculating required energy or energy released are usually dependent on the substance's intermolecular forces, just like boiling and freezing points. The strengths of the intermolecular forces once again determine the amount of energy required to change the substance. Oh shoot, all our water boiled out. Now our ramen's burning.